Hello बच्चों, let's read the question. So the question says, cancer cells are more vulnerable to X and gamma radiations than are healthy cells. In the past, the standard source for radiation therapy was radioactive 60 cobalt, which decays with a half-life of 5.27 years into an excited nuclear state of 60 nickel. That nickel isotope then immediately emits two gamma ray photons, each with an approximate energy of 1.2 mega electron volt. How many radioactive 60 cobalt nuclei are present in a 6000 Ci source of the type used in hospital? Energetic particles from linear accelerators are now used in radiation therapy. So what is asked from us, that we have to find the number of radioactive 60 cobalt nuclei present in a 6000 Ci source. Okay, so let us first revise the key concept behind this question. So the key concept behind this question is half-life. So what is half-life? So it is the time taken by a radioactive source to become the amount half of its initial amount. It is denoted by T half, which is given by natural log of 2 upon lambda. Here lambda is the decay constant. So now, and the second key concept is activity. Okay, so activity is given by the formula A is equal to lambda n. It is the rate of decay of nuclei per unit time. So now, considering these two key concepts, we can jump right into our solution. So for solution part, we have, now we have the T half for cobalt is given to be 5.27 years. Okay, so we can write it here equal to 5.27 years, and let's write it here. And the second thing, we know that radioactivity A is equal to lambda times n, where n is number of undecayed particles. Okay, so from here we can write n is equal to A upon lambda. Okay, so it is T half is also given by natural log of 2 upon lambda. So from here we can write the value of lambda. From here we can write lambda is equal to ln2, which is 0.693 upon 5.27 years. Okay, so it will be 5.27 into 3.16 into 10 to the power 7, because 1 year is equal to 3.16 into 10 to the power 7 seconds. Okay, so this is substituted here to get the time period in seconds. So from here we can put lambda. So this n we have to calculate, and A is given to us as 6000 Ci here. So we will put it 6000 Ci upon lambda is given to us as 0.693 times 5.27 into 3.16 into 10 to the power 7, and we know that 1 Ci is equal to 3.7 into 10 to the power 10 disintegration per second. Okay, so we will substitute it here, 1 Ci. So from here we can calculate the value of n is equal to 6000 into 3.7 into 10 to the power 10 into 5.27 into 3.16 into 10 to the power 7 upon 0.693. On performing this calculation, we get it equal to n is equal to 5.33 into 10 to the power 22. This is the number of radioactive cobalt nuclei. Okay, this is the number of radioactive cobalt nuclei which is present in the CI source, which is used in hospitals. So this is our final answer. Let's highlight it here. I hope you understood it well. Thank you.